In this video, we're going to talk about equivalent quadratic expressions. Question 1 asks us to explain why the diagram shows that 6 times 3 plus 4 equals 6 times 3 plus 6 times 4. So what we are looking at here is two different ways of finding the area of this rectangle. One way that we can find the area is by finding the length of the longest side by adding these two lengths together. So this longest side is equal to 3 plus 4, which is 7. So the area of the rectangle is equal to 6 times 7, which is 42. Another way that I can find the area is by finding the area of each of these two smaller rectangles and then adding them together. So the smaller one here is going to have an area of 6 times 3, which is 18, and this larger one has an area of 6 times 4, which is 24. So the total area is 6 times 3 plus 6 times 4, which is 18 plus 24, which equals 42. So these are two different ways of finding the area, and they both give the area of the rectangle, which is 42. So we know that these two are equivalent. 6 times 3 plus 4 equals 6 times 3 plus 6 times 4. You might remember using the distributive property. That's basically what this is saying. When you use the distributive property, you multiply whatever's on the outside of parentheses by each term inside of the parentheses. So we multiply the 6 here by the 3 and by the 4. Looking at number 2, it says to draw a diagram to show that 5 times x plus 2 equals 5x plus 10. So looking at my diagram here, what I have on the outside of the parentheses is going to go along one side of the rectangle, and then what's inside the parentheses is going to go along the other side of the rectangle. So for this rectangle, I'm going to have 5 on one side and x plus 2 along the other side. Now I'm going to break the rectangle into two parts along this side. One is going to be x and the other one is going to be 2. And now I can find the area of each box and then add them together. So this box is going to be 5x. This box is going to be 5 times 2, which is 10. So this shows that 5 times x plus 2 equals 5x plus 10. Question 3, now we're looking at a bigger rectangle that has side lengths of x plus 1 and x plus 3. And we want to show that x plus 1 times x plus 3 and x squared plus 4x plus 3 are equivalent. So again, we're going to find the area of each of these smaller rectangles and add them together to get the area of the whole rectangle. The whole rectangle has an area of x plus 1 times x plus 3, because it's this side times this side. What about the smaller rectangles? Well, we see that we have this rectangle here that has an area of x squared, x times x. We have this rectangle here that has an area of 3x. We have a rectangle down here that has an area of 1x, 1 times x, and 1 times 3, this rectangle has an area of 3. So we can add all 4 of these rectangles together to get the total area of the larger rectangle. So it would be x squared plus 3x plus 1x plus 3. And we know that we can combine like terms. 3x plus 1x are like terms, and that combines to give us 4x. So we can see that x plus 1 times x plus 3 has the same area as x squared plus 3x plus 1x plus 3, or x squared plus 4x plus 3.